start talking. Okay.
Meters, twice a trillion.
So my name is Darren Davis. I'm here to talk about Appendix B. Is this mic too much? Okay.
You can turn it back on.
Yeah. Okay, so first of all, what is Appendix B?
It's the one after Appendix A.
There we go. Okay, so it's a 10-page document in the back of all research classical safety standard. It's supposed to improve the safety of personnel and gear used to deploy oceanographic instrumentation. What does it apply to? I heard a lot of conversation about this a little bit ago. Well, is this a handling system? Is that a handling system? So it applies to gear used to lower things below the surface of the water, used to drag or tow things in the water, and it has to include a tension member that's paid out beneath the surface of the water. Becomes the line pull at the head sheet or winch drum. Basically, the tension member has to be hooked up to everything else in the system and pull up, right? It all seems pretty simple, but I always get a lot of questions about this, so I made lots of doodles.
Oh, nice.
So you can go through my doodles, and isn't the weight handling system. I'm sorry in advance. And all my slides, I call it wet weight handling gear. That's what federal regulation refers to it as. Our community calls this an overboard handling system. I should have put that. I can't even say wet weight handling gear, as you'll see here pretty soon. So my first example here, it features a winch in red, a frame of some sort in purple, a tension member in pink, a tension member in a cable, a wire rope, and a thing that we're deploying underwater. So it has 3 features making it wet weight handling gear. It's being used to lower a thing under the water. It has a tension member that's below the surface of the water. Tension member that is transmitting its force to everything else, right? So here's another example. Again, we're deploying a thing instead of just lowering it into the water or taking it out, we're dragging it behind the ship. But it's all got all the features we're looking for, primarily a tension member underwater. Okay, is this an example of an overboard handling system?
Yeah.
It doesn't have a tension member underneath water. What about this one? Nope. No tension member underneath the water. What's that? So we got a thing, but it's kind of underwater, it's kind of around the ship, and it's kind of almost to the winch. Might even be wrapped around the winch. What might this be?
Big net.
A net? How about a mooring? Right? A mooring or a streamer?
Yeah.
That's still our thing. That's our thing, right? So
Even if the thing is a tension member, like in a mooring?
yeah,
Tension member is not in the water.
even if the thing is a tension member, it's still our thing.
I'll take it.
Excuse me. This is something that the safety committee has discussed. We've come to consensus on, and we've discussed this with the Coast Guard. They agreed that that's still a thing.
Okay.
So, there's your core. What about that? Is that an overboard handling system? A purple robot arm? No, there's no tension member. Okay. So why is our focus on this tension member?
There's a lot of tension there.
Right. So the reason why we put so much focus on the tension member is because the worst thing that can happen to a whole overboard handling system is when we suddenly snag something on the bottom of the ocean. Ships have a tremendous amount of energy. If we just hang them up on something, it's not going to stop the ship. So something's going to break, and we don't want it to be the stuff on the ship. We want it to be the tension member. That is going to be the least risky as far as money and as far as personnel behind it. Okay. So in Appendix B, there are rules for here. They include how strong it has to be, how we must test it, that is to confirm that it's still as strong as we think it is, how we must label it so people random passersby and operators can see that's definitely strong enough for what we're doing. We have to train people because all that other stuff doesn't mean squat. We just put Joe Blow, behind the wheel and he's crashing it into things. And how we must document our efforts because we do have to demonstrate we're doing all these things to inspectors and other folks. So first design rule, how strong it has to be. Okay, one of the first rules has to do with how much stress can be in the gear. And just so we're all on the same page, what I mean by stress is when you apply a force on something, the inside of it squishes in some places and stretches in other places. That's kind of a measure of how much stress you're putting on the material. When you stretch something, okay, so you put a small force on this beam here, and it just gets a little bit of squish. You remove the small force, and it snaps back into shape. Okay, that's acceptable. If you put a really big one, and you squish or stretch, the stress is too large. You exceed what's called the yield point of the material, and it never comes back into shape. It's ruined, right? So we don't want our gear to be ruined. For that reason, yeah, the rule in Appendix B about stress is whatever the yield stress, whatever the stress is at which the thing's going to get ruined, your handling gear, divide that by 1.5, and that's the most stress you can ever put in the system. Makes sense. And then as far as minimum strength, as far as the inspected vessels go, that's the big ones, inspected by the Coast Guard. For inspected vessels, system components have to be designed at a minimum to withstand and operate in excess of the nominal braking load of the strongest tension member used. So what does this withstand and operate mean? Friction, especially with some manufacturers sometimes about what that means. It means that the system has to be entirely undamaged and operable after being pulled on until its tension member breaks. It also means that while it's being pulled on, the wet weight handling gear must hold fast. The brakes can't slip, for example. Hydraulic cylinders can't leak and move, for example. It has to be hold the same position. It does not mean that weight an overboard handling system hard enough to break their tension members. So that's cool. Effective vessel rules are a little bit different. They're a little bit more lenient. A system does not have to be strong enough to break or withstand the breaking strength of its tension member if we use a weak link, for example. A weak link being something that's going to break well before the tension member. You can use a weak link, like we do that with dredge. We put a weak link on the dredge so it gets hung up. We don't break the tension member and the gear on board, it just lets it go. Torque limiters, these can be a part of a winch, for example. If if a tension that's too great for the system is applied to the system, a mechanical means or a hydraulic means of some sort allows the winch to rotate until the tension is removed, until the tension is back to an acceptable limit. It has to be automatic in nature. People don't just operate it. It can be, there were specific examples here. It can be a relief valve, it can be a clutch of some sort. And then we have an auto render system. Now this is, the former was hardware that does the torque limiting. This is software doing the torque limiting. So the system has features that sense the tension. If it's too high, if it's a winch, for example, it'll pay out a little bit until the tension is acceptable. Once again, it has to be automatic. It can't require a user to do this. And then has to go back into a normal state of operation after the excessive tension is relieved. Another design rule is you have to consider, sometimes when you're pulling on a structure, it matters what direction you're pulling on. Like a tree, if you're pulling straight up on it, it's going to withstand that. If you pull sideways, it's going to bend over or break. The same thing goes with our handling gear. Oftentimes you have to consider all the various ways that it's going to be pulled on when you design the system to make sure it's going to withstand what you're doing with sea. And there are design features that you should be including in your weight limit in your overboard handling system. Yeah, I told you guys that. It has to have safety guards to guard against pinch, dangerous rotating equipment so people can't get tangled up in it. Signaling devices, it should have some sort of light or sound or something when it's being operated so that people know it's being operated, especially if it's being operated somewhere else. Somebody could be standing there and not know it's even active. Every stops need to be at all the operating stations and local to the equipment. Sometimes the operating station is somewhere different. That way, if somebody's standing by and sees a problem, they can stop the equipment. It needs to feature electrical safeguards. That's a breaker or fuses to prevent electrical overload. It's also a means of tagging out things, like if you're going to work on it so people don't get hurt. Manual operating devices. They have to be what they call the dead man pipe. And by operating device, I mean like sometimes the witches have little joysticks that you can pay out and haul in and stuff. They have to be a dead man type, meaning that they have to require constant user intervention. So if you imagine like the operator just like falling over dead all of a sudden, it would just like snap into neutral position and not operate anymore, stuff like that.
Quick question.
Yep.
If you put like a foot pedal in series with that, same thing, the operator, the stick might still be forward, but if your operator falls over and takes his foot off the pedal,
Yeah.
now it's been.
Yeah, as long as it requires the operator's intervention.
Okay.
Yeah. And it suggested that we get a maximum capability document with our equipment. If it's brand new, because they're free at that point for the most part. If the manufacturer has to go back and dig into records, you might not get one for one, and for two, it might cost you a lot of money. And just so everybody knows, the maximum capability document is a document that says basically how strong something is. You know, at what maximum capacity are we following all the rules that I just mentioned? The rule for the strength and the rule for the maximum stress. So, having gone past all the design rules, there's rules as to what has to happen when you install a piece of equipment. Install it with the manufacturer's instructions. That seems pretty straightforward. If it comes with guards, make sure they're in place. Post-operational limitations, whatever they may be, that could be as simple as like stenciling safe working load on it or something, or don't hit the green button, whatever you think is necessary. Don't sink the ship. If it's a big piece of equipment, you should be talking to the vessel operator and or captain to make sure the stability of the ship's going to be okay with this on board. Then we move on to testing. Appendix B says that we have to test things because hopefully they were designed to be strong enough, but we need to test them to make sure that the engineer didn't screw up, the fabricator didn't screw up, the installer didn't screw up, and so on. We have to test every piece of what weight handling gear. So every shackle, the tension member is covered elsewhere, but the tension member, each component that's part of the handling system. We need to try our best as we can to test it as it's used at sea. Except that deck hardware, I'll get into that in a second. Test and assess it when it's new. There's an assessment that has to be done when it's new. In addition to the test, whichever, so I'm calling test as a weight test, but weight on. The assessment is an examination that you do. I'll get into that in a second. After the initial testing, when it's installed, we test it every 5 years after that. And that's no longer really to make sure the engineer and so forth did their job, but things rust in hidden places at sea. We found that out when we took a boom off a Revell. Our squirt boom was like half gone inside. It was cleverly designed to like hold water on one end of it. So we had to scrap half of the boom and make a new one. Good thing we were testing it, because if it would have gotten any worse, we probably would have broke something. The initial testing that I said earlier, we make sure that the gear looks suitable for what it's used for. This is the assessment piece, I'm sorry. We test each piece as it's used to sea to 125% of its safe working tension. The safe working tension is the greatest tension that's allowed to be on the equipment in a, daily basis. That's something that's usually specified by the manufacturer. They might call it the working load limit or the safe working load. We call it safe working tension. We remove all access and covers and inspect it after test. Make sure that everything looks like it's still okay. If you think something broke, if it makes a weird noise or have something bad happen, definitely don't just give it a cursory glance. Then after that, every 5 years, we don't have to do the assessment anymore after the testing, but we have to do the weight test, 125% of the safe working tension. That's to make sure, once again, it's not being eaten up by corrosion. The thing you crashed into, didn't hurt it, who knows. So as I mentioned before, we treat that hardware a little bit differently. Obviously, if it's a part of the system right now, then it'll be included in like a system-wide test you go on the ship or something. But the bosun has lockers full of this crap, and you can't test every single piece. So what we do instead of testing is we inspect these things. They're tested at the factory and they have a high safety factor. So we just make sure that all the writing on it, all the things that indicate what strength or what its capacity are still legible. Like it's a shackle or a paralink, it still says 5 ton or whatever. We make sure it's not obviously tweaked, and we throw it away if it's no good. Yep.
Just want to comment on that last slide.
Yep.
Is, a lot of hardware repair rings might come back from the mooring, and moorings have been sitting out there for 2 years, and they've been stretched and fatigued.
Yep.
So you've got to be careful about that kind of hardware that the ship captures and throws into their locker.
It's true. And then obvious one sign of like a lot of use or something. Sometimes these get like little wear spots, and then where one component rubs against another. If you got a pretty good notch go in there, then I chuck it in the trash can.
All right,
Yes.
make sure you get it from a reputable manufacturer.
Yes. Yes. Make sure it's Crosby or whatever, Chicago.
Yeah.
Directly from the manufacturer, preferably, because there's a lot of counterfeit garbage out there.
No Chinese.
Except for that shackle that's on top, throw those at the garbage.
These here, oh yeah, without the galvanizing.
Yeah, the pin diameter is the same diameter as the bottom. And the nuts can actually back over the cotter pin, so I've seen it happen. So
Okay.
if that little piece on the end with the cotter pin goes through,
Mhm.
is the same diameter as the inside of the threads,
Mm,
get rid of them. It'll back right over a cotter pin.
okay. So deck sockets, something about deck sockets. So deck sockets, once you have a winch or something attached to them on the deck, they're part of the overboard handling system, right? So we have to test them. But we don't use every single deck socket on the deck. We have them on the O1 level on some ships. You don't have gear up there. You just have to test the ones that you use as part of a handling system. I mean, ideally, you install the whole system on the ship, you test the whole system, and then the deck sockets involved are being tested as they're usually seen. There's other ways. There's machinery that's been created to test them individually. That's one way of doing it.
I think the
Seems like a
Bowie
time
Marine,
consuming.
I think the Bowie Port Office is buying a hydraulic that's portable, and it'll be a cooled piece of equipment,
Mhm.
so.
Oh, that'd be cool.
That would be crazy.
Where I'm, yeah.
Totally access.
Where's Ethan? I thought Ethan that one was
Yeah,
on.
they haven't been able to,
Yeah.
Yeah, a company called Einhorn Engineering created a system for testing deck sockets, and I believe we're buying one as well. I believe.
They came to us and said they wanted the winch pool to buy it, and then it makes,
Right,
the port office worked out a deal and they're gonna buy
right,
one.
right.
Melcor had one several years ago, I assume they still have it.
Mhm.
Are these vertical poles or 45?
Both.
Are they vertical or 45?
For the tester that they're talking about. When you pull it,
It'll do both.
yeah.
There you go.
It has a configuration you can change on it and it'll pull both,
Does it need to be?
It's 92, right?
90 and 45,
And then what about horizontal?
that's 45.
Well, 45 is that
Right.
way, this way is 90,
No,
and
not
it's
that.
vertical,
Not directly, no,
no?
but that's what you did
Yeah,
years ago.
yeah,
It
Yeah,
was all free.
right.
Oh, okay, I
Now
thought
it's-
the only two required, I don't know.
Well, what is required now?
use it as it's tested like it's used at sea. That's what, it's kind of complicated. So that's what I say, the best way to test a deck socket is to, you know, install the system. I mean, sometimes some ships do that. Some science parties do that. They install the whole system on the ship. They test the whole system and everything's tested just like it's done at sea.
If you get a
Translating
ship,
like how much pull this way and that way is like you're using it.
Complication
Yeah,
with
it's
that sometimes is the 125%.
Yeah,
getting the right sentence, and right pension member can be a limiting factor.
That's. Question,
Mhm.
right, so if you install the whole system
right.
and you test it to 125%, you don't have to. It's independent, right?
No. It doesn't matter if you test things individually or as a system, preferably as a system, but as long as everything gets tested the way it's used at sea, then you're covered.
Okay, you're right, so if you,
Right, so I mean, sometimes we have. It's easier to do with some things than other, like we have a whole pile of logs, you can just send those to the rigging shop. There's no problem, no sense of making a system which each log. But whatever, just whatever's most effective and works best.
But that, in that example, if you put it using those same sockets.
Right.
They're not tested for light. It's tested.
For that. Part of that system, right. Winch in the same spot, maybe with the wire rope going a different way, that would have to be tested too. I mean, that's the tricky part with the deck sockets,
These are every 5 years?
every 5 years. So the next thing. Appendix B talks about labeling. We specified how strong things have to be. And how to verify that they're that strong. This is labeling them so that the strength is known, so random passersby, operators, whoever. We label our equipment with a test date, the safe working tension. And if possible, a diagram. With a lot of systems, it's kind of complicated. It'd be hard to put a diagram for an A-frame, you know, on the side of the frame, because it could be pulled on in any number of directions. But something as simple as a block, you know, there's a little example that I got off a Harkin block. They show different capacities and different angles and whatnot. And deck hardware is a tough one. Really, I think the only good way of labeling it is after you inspect, if you were to inspect all your deck hardware as a lot, I just color code it, spray it all pink, something like that. And then because your logs, later I'm going to talk about logs, your logs have to be sufficient to determine how when every piece of gear has been tested. So unless you want to put a serial number or a label on every single shackle, that's, you know, spray paint. And then if one that's not the right color shows up, you know that hasn't been tested, throw it away or test it. Logs. So we have to keep logs to verify that we've done all the right things, to make sure that everything is strong as we think it is and remains that way. We keep logs with a test date, recording the tests that we do on our equipment, what method we use, which means you have to use a written procedure with a name. The names of who did it. And also you need to make entries whenever something that would affect the gear's strength occurs, some sort of casualty. We need to log the inspections. When something is repaired. When we make a major repair or something, we need to test our gear too. So we need to log that. I don't think I said that earlier, did I? Yeah,
Oh, you didn't, it's not.
Yeah. if we make a major repair or something, we need to test it too. Yes. Make that change later. We have to train our operators so that all this effort is not wasted and people don't get hurt anyway. We have to have a formal training procedure for our handling gear. All operators that operate the gear have to complete the program. Every year, everybody has to be retrained, refresher training, not the whole shebang. And our training system program has to include audible records. So we have to have some sort of paper record saying this person was trained. That said, hypocrisy, the winch pool has not had a formal training procedure for our gear. The effective one. We've had, I've had a checklist basically. My thinking was if you just read this checklist, you know everything good to go. But we're gonna start working on some formal training programs. My thinking is if we just have a regular training program, I can give you the training on a cell phone. You know what I mean? Just do an online meeting of some sort. Oh, and not last thing. Okay, this is the last thing. We're supposed to keep an OHS operator's manual. And what this is, all these things I talked about before, if you're complying with them, you've got documents saying how strong things are, when you tested things. This is basically just a pile of these documents, all of them, all in one spot for the most part. It should include a detailed description of the OHS layout. That's something you need to know if it was portable gear, for example, where the gear goes, how it's oriented. The test procedure you're using. Procedural safety requirements. That's something that's probably experience that you've gained while operating it. That's not in the manuals that you compile for it or whatever. Start that thing before you start stuff like that. Don't move the squirt boom if if you're hard up against the lock. Operator training procedures, references to component manuals and data sheets. You don't have to put all your manuals all in this manual. That would be kind of redundant, and some of our systems have really thick manuals, so look for a very large document. But do just write down, a list of all the manuals you have and maybe where to find them, data sheets, and your maintenance procedures. This is especially important for our portable gear. You send your operator's manual along with your portable gear, the person that's using your gear can see these are the things that we have to do to keep it alive at sea. Another thing that I need to do.
That's all I got.
Yeah, if you have any questions, call my boss, Captain Gallagher. And or me. That would probably make the most sense. And that's all I got. Questions?
I'm just curious, are you available for remote support of fleet-wide winch and OHS systems that are permanent installations on board those vessels?
Yep. I'm here to serve you guys in any way I can.
Okay.
Aaron has set up a sample, which I've distributed to some ships of the OHS manual. So if you want a sample, get from him or from me. And one thing I had him asked him to put in was kind of an executive summary at the beginning. One thing that fell out, maybe the latest version of Appendix B, was a summary, or somewhere in the manual says, what's the overall capability of the system? It doesn't show up now as required in the manual. So the example that Aaron did for me, he included that segment there. So the person picking it up could look into effectively an executive summary and say what it's used for and what's its capability. And then you get into the other things.
Yeah, if you guys want an example of any of these documents, what's the training program look like for a handling system? What is an overboard handling system?
Draw a custom doodle for us.
OHS operators manual, what does that look like? I can give you an example. I found that when compiling the OHS operators manuals, everything's a PDF document these days coming from the manufacturers. I just use Adobe Acrobat Pro. I just stick them all in a big pile and then tell it to number the pages. If I need a cover sheet on something so it's clear what it is, I just do that in Word and stick it on top. Yes, sir.
Does anybody here know how Jason, with their over the side handling equipment, they have their own
Yes. They'll tell you they've tested it.
winch and their own?
They'll tell you they've tested it. They can show you the documents if you want to see it. That's exactly what they told me about 6 months ago.
Well, they didn't test your deck socket.
They sure didn't.
Because that's something that obviously the operator and or the master, they're taking on the responsibility for that gear. Yes, sir.
Another comment is, Aaron made up a assist sheet for Appendix B. And in terms of inspection, we send out ahead of time and ask for a self-assessment of how you're doing on Appendix B. So thanks to help that for everybody to help us get moving ahead.
Yeah, so I've got that available if anybody wants a copy. I don't want to tell if anybody has a question online. Online. That's all I've been.
If you talk to me. He'll tell you what they do, but. He'll go into detail as much as you want, but. They test their here in-house.
They have a deck layout in their new shop. Tie down pattern, and I'm assuming that's, yeah, how they're using it. Tie their equipment down, test it somewhere, I don't know how they work it, yeah, I know that we've got to sell them all.
Great detail.
All right, so. All right.
Thanks, Aaron.
Thanks.